Hello, my name is Ricardo Gonzalez. I'm a product manager for the high availability and scalability product management team. We oversee all MA aspects of the database, high availability, scalability, so everything has to do with real application clusters, clusterware, ASM, ACFS, flip patching and provisioning, data guard, you name it. I am the product manager for the Zero Downtime Migration product, ZDM, and for the ACFS cluster file system. So today I'll be talking about cloud migration, specifically about our latest release, ZDM 21.2, which was released recently. And I'll be talking about the overall product, how it works, different migration methodologies, new features and functionality, and also helping you out on understanding what are your migration needs and how to actually move your database to the Oracle Cloud using ZDM. It's my pleasure to be here with you from San Francisco, California, where I'm based. And I'm quite happy to be talking about ZDM. Let's get started. This is today's agenda. We'll be talking about the overall Zero Downtime Migration product, ZDM. I'll be doing an introduction of product and then talking about what's new in 21.2 and of course an overview of the architecture and overall migration workflow. We'll be then drilling down into the physical workflow, how it works, sources, targets, and a step-by-step guide of how it actually plays out during the migration. And we'll be doing the same for the logical workflow, sources, target, how do it work, logical online, logical offline, and different things that have to be taken into consideration. Then at the end, I'll be sharing some resources for you so that you can actually use them for your migrations. And of course, we're going to have time for a Q&A. So let's talk about ZDM and how to migrate your database to the Oracle Cloud. Oracle ZDM was created with the idea to be a simple product to help you with your migration completely within the Oracle MAA best practices, providing zero data loss and a completely secure and free way of migrating your database workloads to the Oracle Cloud. ZDM as a product uses a simple architecture in which you download the ZDM binaries, install it and configure it on a box that is running on Oracle Linux 7, and then you pre-fill a response file that has information for the source database, target database, and different aspects of the migration as methodology, etc., then issue a migration command. ZDM will then connect to the source database and the target database in the cloud and perform some validations, and when it's ready, perform the migration for you, automating the whole process. It has different ways of working, either physical offline by using a backup and restore methodology. With Arman, it could be physical online using data guard, it could be a logical offline using a data pump, or it could be logical online using a combination of data pump and Golden Gate. Overall, we complete the whole stack of migration solutions of Oracle and provide the best-in-class automated tool for moving your database workloads to the Oracle Cloud. So ZDM follows a single button approach, making it a simple way of migrating. As I mentioned, once you have ZDM installed and configured, you just need to fill a response file that has information on the source database, the target database, backup location, and the migration methodology. Upon that file being ready, you issue a migration command, and then ZDM takes care and orchestrates the whole process. As a product, ZDM is fully comprehensive. It follows all the MAA precepts and is fully MAA compliant. When migrating, there is an extensive pre-check of the source database and the target database to be sure that everything is fine. There's also a post-check to be sure that the migration was done properly. You can pause and resume at will. You could also say, ask ZDM, hey, I want to pause when you reach a certain level of the migration, so I can do some testing and then resume. We have a dry run option, which basically means that you can run a migration in evaluation mode, meaning you will not be migrating, but actually evaluating what would happen in case the migration will be to take place. So in that way, you can actually go ahead and evaluate what could happen, and if there's anything that you need to course correct, you'll be able to do so before actually doing the migration itself. We also take care of the encryption of the target, because we understand not all source databases are TD enabled and encrypted by default. So if your source database is not encrypted, that's fine. We take care of that at the target level, since all databases in the cloud are encrypted by default. the product scales to a fleet level, so you can actually have multiple databases. We can migrate single instances, rack databases, rack one node, and multiple databases at the same time. Since we follow a job framework, that means that once you issue a migration command, you can then keep issuing new migration commands for new databases and have multiple migrations in parallel. We have a comprehensive set of logs, so we have quite a robust audit trail, and also you can schedule operations. So you could say, I want to migrate my database Friday at 3 a.m. when nobody's connected, and then when I come in the morning, I check and the process is done. So it's quite a comprehensive and powerful tool. Here we have a really good overview of the Zero Downtime Migration part. As you can see, you have different storage databases that are supported. You have Standard Edition and Enterprise Edition Oracle databases on premises, Oracle databases running on AWS RDS. We support databases from 11.2.4 onward. For targets, ZDM can migrate databases to Database Cloud Service Bare Metal, Virtual Machine, Exadata Cloud Service, Exadata Cloud Customer, and Exadata on premises. Also, ZDM can migrate databases to the Autonomous Database, both Autonomous Transaction Processing and Autonomous Data Warehouse. ZDM can migrate databases that are hosted on Linux platforms, AIX, and Solaris. Also, ZDM can do non-CDB to CDB conversion of databases during the migration process. We support different methodologies such as physical migration and logical migration. If you're performing migration from, let's say, 11.2.4 to 19C, that's possible through the logical migration workflow, which means that you can do an in-flight upgrade of your migration. And ZDM relies on different technologies to perform its migration. So we have different migration methodologies, right? So it could be an Armin backup restore methodology. You use DataGuard, Data Pump, and Golden Gate. So overall, it's quite a comprehensive and powerful tool for your migration. Now, what's new in Zero Downtime Migration 2022? We have introduced now Oracle databases running on AWS RDS as source databases that are supported with the logical offline migration methodology. Now, databases that are running now on source platforms such as AIX and Solaris can also be migrated using logical offline migration methodology. Before, we only supported Linux sources. Now we support AIX and Solaris. We also have the physical direct data transfer methodology included in the physical online migration method. That means that you can actually do migration without having the need of having specific use of object storage or a backup location. Also, ZDM creates an L0 backup, an L1 backup when doing physical migration. Now, if you already have backups in place, we can reuse those existing RMM backups for certain scenarios for physical migration. We have further migration enhancements such as table space automatic remapping, etc. And we also have some cool new migration advisor enhancements, such as being able to update directly from the ZDM home the migration advisor, etc. So there's a lot new in 21 to ZDM. As mentioned, we now offer support starting in Zero Downtime Migration 2022 for source databases, Oracle source databases running on AWS RDS. These supported via the logical offline methodology using data pump import export, and ZDM can migrate the database transferring data via an S3 bucket or using DB link to an autonomous database as a target. Another great feature introduced in 21.2 is having databases on different source platforms in Linux. Now we can migrate databases that are hosted on AIX and Oracle Solaris using the logical offline methodology that Zero Downtime Migration offers. As part of ZDM's architecture, there is the need for an intermediate store for backups. For OCI-based migrations, we use the Oracle Cloud Infrastructure Object Storage. For Exadata on-premises or Exadata Cloud Customer migrations, we can use NFS or we can use the recovery appliance. Now, starting in 21.2, customers that are using the physical online migration methodology can leverage a new feature of direct data transfer, thus avoiding the need for that intermediate store for backups and having a faster migration experience. Depending on the database version, it could be used based on active database application or restored from service. As part of the physical migration workflow, ZDM creates L0 backups and then transfer them to a backup location. For them to be instantiated into the new standby database. Starting in 21.2, ZDM can actually reuse existing L0 backups that have been created by the user, and hence will skip this phase, thus providing a faster migration experience. So we can now reutilize existing RBAN backups in the case we were already there, of course for certain migration scenarios. There has also been new migration enhancements in 21.2. Among them, when we're doing data pump dump size estimations, we can also now do it via the statistics method. Now, for the logical workflow, there's an automatic creation or remapping of table spaces from the source to the target. Any user provided action script can now be modified locally and updated in the user action metadata. And while the migration is taking place and there's pause of it, users can also do some to a certain extent, modification of responsive parameters for logical migration only. Finally, 21.2 introduced some pre-migration advisor enhancements. Now, the pre-migration advisor tool can be updated directly from the ZDM home, and any remedial scripts that are provided by the tool can now be run and automated directly in the ZDM tool as well. Now, having covered the basic introduction and overview of the product and what's new in the latest release 21.2, let's move on and talk about the different migration workflows that ZDM has to offer. So the first workflow we're going to cover is the physical migration workflow. ZDM offers the physical migration workflow in 3 different flavors. You can do physical offline migration, which is basically a backup and restore methodology. You can do physical online migration with DataGuard and a backup location, and you can do physical online migration with DataGuard and direct data transfer. Now, physical migration covers different sources and targets. As you can see here, we start with 11.204 and then move onward. Now, databases in the physical migration workflow can only be migrated to a database at the same version level. So you will do 11 to 11, 12 to 12, so on and so forth. However, the target could be at a higher patch level, and we just will apply data patch at the end of the migration. ZDM physical migration also covers the non-CDB to the PDA conversion if you want to. It's just easily modified and set up with a parameter at the response file level. Now, we support Database Cloud Service virtual machines, bare metal, Exadata Cloud Service, Exadata Cloud Customer, and Exadata on-premises with the physical migration workflow. Here we have an overview of how ZDM's physical offline migration works. As you can see, this is perfect for standard edition customers, but also used by enterprise edition customers. For physical offline migration, ZDM uses an RMAN backup and restore methodology. The way it works is as follows. You download and configure ZDM and provide all the relevant information to ZDM's response file. Then issue the migration command, and then ZDM starts the database migration, will connect to the source database and the target database in the cloud via SSH, will then connect to the backup location and start transferring different backup files. Then ZDM will instantiate the target on the cloud using those backup files, perform a switchover, and finalize the migration process by cleaning up all the environments and having the application connected finally to the target database in the cloud. Moving forward, we have ZDM's physical online migration. It leverages DataGuard, so it's only for source databases that are Oracle Enterprise Edition. The way it works is as follows. You will download and configure ZDM, provide all the relevant information for the response file, and then issue the database migration command. ZDM will then connect to the source database, to the target database, and we'll do check in each one of them, and then of course connect the primary database to the backup location. We'll then transfer all the database backup files from the primary to the backup location, use those backup files to do instantiation of a standby database, then establish SQL connectivity to synchronize the primary and the standby. Then once everything is in sync, do a switchover and a role swap, and then of course finalize the migration process and do a proper cleanup. We will go more in depth in some slides ahead, of course. Starting in 2002, the physical online migration also added the possibility of doing a physical direct data transfer. This works quite similar as the previous workflow, but let's just dive into the differences. So again, we download and configure ZDM, provide all the information, and then ZDM will start the database migration, connect to the source and the target, and orchestrate a direct data transfer between them, then instantiate a standby, synchronize both primary and standby, and perform the switch over and the role swap, and then finalize the migration process. Thus, we avoid the need for the external backup location this way. So now let's actually go back to the ZDM physical online migration with backup location and see how it works step by step and a bit more in depth. The first step is to download and configure ZDM. ZDM will run on a box that is on Oracle Linux 7. It could be the same as the source database or the target database. Just bear in mind that it should never be where there is a clusterware home running or GA home running. Now, we've also tested tests where ZDM is in OCI on a virtual machine. That's completely fine as well. Now, once you have downloaded, installed, and configured ZDM, what you have to do is there's a response file with information of the source database, information of the target database, connectivity information, backup location, etc. That needs to be filled with the right information. And when that's done, then we move to step number 2. You will then issue the migration command or ZDM CLI migrate database command. Then ZDM will start the database migration workflow, which means establishing SSH connectivity to the primary database on premises, establishing SSH connectivity to the target database and target database cloud service, and being sure that everything is in place, database version, etc. Then ensuring there is connectivity to the backup location, and overall, ensure the migration process will continue. And then ZDM will move forward with the next step in the migration. ZDM will then proceed to connect the source database to a backup location so that we can start transferring backup files. That will be the next step. But bear in mind that the backup location can change depending on your migration destination. If you're migrating to any OCI native database, then the backup location will be the object store. If you're migrating to Exadata on premises or to Exadata Cloud Customer, the migration backup location can be external NFS or the recovery appliance. Now, as part of the migration process, ZDM will create backup files from the primary database and will transfer them to a backup location. As mentioned previously, this backup location can be the object storage, NFS, or the recovery appliance depending on the target. ZDM will have to transfer all those backup files to a backup location since they will be used for the instantiation of the standby database. So ZDM will take some time by creating these backups and then doing transfer to that backup location securely. In the next step, Zero Downtime Migration will use the backup files that were transferred from the primary database to the backup location and leverage those files to instantiate a standby database in the cloud. So now you have a standby database in the cloud, and that's great. That's perfect. But remember that database is still not yet synced up with the primary database because the database was instantiated using backup files, and then whatever happened after the backup file creation and transfer to the object storage or backup location is not recorded there, right? The primary database is still connected to the main application and there's still workloads going on. So that standby database is still out of sync, but it's great. We have a great process going on, and we have to move on for the next step where ZDM will actually sync up and do the rest of the work. The next step, as mentioned, is ZDM doing a synchronization between the primary and the standby. This synchronization happens because ZDM instructs the primary to establish SQL connectivity between the primary database on premises and the target, where it's now a standby database, in the cloud. Now let's stop for a second there, right? This is really important and it's relevant for a highly available and online migration because this way we can actually sync up with databases and follow for the switch over, which will happen next. But really important, this could be then a setup for a DR or disaster recovery setup, which you have your primary database on premises and standby on the cloud, or if you continue with the actual switch over and role swap, a disaster recovery setup in which you have the primary database in the cloud or the standby database on premises. Now, there are several things that are important here to bear in mind. For instance, the primary database might not necessarily be TD enabled, meaning it doesn't have encryption by default on your premises at the source level. But all databases in the cloud will be encrypted by default, and it will have TD or transparent encryption enabled. What does this mean? Well, ZDM will take care of the encryption process for you, so you don't have to worry if your database or primary database on premises is unencrypted. The standby database in the cloud will be encrypted, and whenever we do the switch over and role swap, everything will be working perfectly. But let's say you want to have a DR solution, or you want to pause the migration when ZDM is already has set up the primary on the cloud and you have standby now on premises. This is when it's important to bear different details in mind. Why? Because the database in the cloud will produce encrypted read logs that will be shipped to the standby on premises. This is if you pause the migration or you use ZDM to set up a DR solution, right? That means that the database on premises will be receiving encrypted read logs that will not be usable for the database unless you enable TD on the on-premises database. And this has certain implications, right? First of all, you need to have the advanced security option, but also, and more important, for 11.2 and 12.1 databases, enabling transparent encryption is an offline operation. So that means downtime. For databases 12.2 or onwards, is an online operation, and it can be done then in an easier fashion. So it's really important that you bear all of these details in mind. However, if you're just migrating and you're not going to pause and you're just going to do the migration in one go, then it's all fine because we take care of encryption for you. The target will be encrypted on an automated fashion by default, and all it's good to go. Then the next step, of course, is where ZDM will perform the actual switch over and role swap. So let's see how that works. Of course, the next step is for ZDM to perform a switch over and a role swap. So now the original source database is a standby database, and the target database is a primary database, and the application is pointing to that primary database. And of course, ZDM automates all this process. Now, there's a clause or parameter in the ZDM CLI migrate database command called pause after, and that like flag or option allows for ZDM to actually pause at certain stages at will. So basically you say, I want to pause after the switch over and the role swap and keep the synchronization going so you can perform all the testings you want, and so on and so forth. So this could be a good way to do this. Or if you want, just issue the migration command without the pause after option, and ZDM will continue with this step, and then what comes next, which is finalizing the migration process. Once everything is in place, ZDM is ready to wrap up the migration process. This entails they ensure that the target database, which is now primary, is perfectly fine, doing pause checks and validations on that database, and then doing a wrap up by cleaning and ensuring that everything is finalized as in connections, connectivity, etc., cleaning up the source environment, target environment, etc. Once all of that is in place, you have an application pointing to the primary database in the cloud, and you're good to go. The ZDM has finalized the migration process. We have now covered all the different aspects for the physical migration workflow, be it physical offline migration, physical online migration with the use of a backup location, and physical migration, online migration with direct data transfer. Now let's move on to logical migration workflow. Logical migration was introduced in ZDM in the 21C release. This logical migration workflow is a game changer because it allows for many different things. First of all, it allows for cross-version migration. That means that if you're coming from 11 to a 4 database, you can migrate to a newer database. If you're coming from a 12C, let's say, you can migrate directly to 19C, hence performing an in-flight upgrade, and so on and so forth. You can also, of course, migrate from the same version to the same version, but logical migration allows for cross-version migration. You also have non-CDB to PDB migration, which is great, and which, of course, that also includes the physical workflow, but yeah, in this case, it's also included in the logical migration workflow. And also, there's new target platforms. You can now migrate to the autonomous transaction processing, both dedicated and shared, out to the autonomous data warehouse, both dedicated and shared. Of course, you can also migrate to database cloud service, virtual machines, bare metal, Exadata cloud service, and Exadata cloud customer. The only non-supported target with the logical migration workflow is Exadata on premises. Now, let's talk a bit more about how the logical migration workflow works. In ZDM, the logical migration workflow has different flavors. It can be logical offline with the use of a backup location, or database links, and it can be logical online with the use of a back application and or database links. Now, we'll start and see each one on a step-by-step basis, but we'll start with a logical offline migration workflow with a back application. As you can see, this is a perfect method for all types of databases, Standard Edition, Enterprise Edition. It's also the support method for Oracle databases hosted on AWS RDS and migrating them to a Tonneau database. It's also a support method for cross-platform migration, so when you're doing migration out of AIX or Solar Resources, this is really the method to go. Now, how it works? Well, logical offline migration with the back application works as follows. Of course, you download a Configure ZDM and provide all the information to the response file and then issue the migration command. The ZDM will then perform all the different validations, connect to the source and target, will connect to the backup location, we'll do an export via data pump from the source database to the backup location, then we'll do an import of all the data pump dump files that are in backup location to the target database. We'll use then that to instantiate a target database, and when it's ready, we'll perform a switchover and finalize the migration process for you. Now, the next methodology is the logical offline migration using database links. As you can see, the actual architecture is the same and quite similar to the one we used before for logical offline with a back application. The main difference is that we don't have a back application, and the connection between the source and target is straight and is done with the use of database links. So basically, there is no need for ZDM to transfer data pump dump files to the object store or a back application, but actually it's done directly via database link. Now, this method is not recommended for databases that are larger than 100 gigabytes, and we do this because, of course, we want to maximize and do migration as efficient as possible. So we do this only, or recommend this only, for smaller databases. Now we move forward to the logical online methodologies. There are two flavors here: either logical online migration with database links and logical online migration with back application. Let's go first and see how the logical online migration with database links work. In this case, ZDM will leverage a Golden Gate Hub that is an OCI. The Golden Gate Hub is done using an OCI marketplace with a specific microservice for Golden Gate for database migrations. And ZDM will use it to actually synchronize the database before on-premises and the database in the cloud. Now, how does everything work? As usual, you download a Configure ZDM, put all the information in the response file for source, target, etc., and then issue the migration command. ZDM will connect the source and target via database link. We'll then configure the Golden Gate microservice from the OCI marketplace image in the Golden Gate Hub, which is now an extract that will start capturing source database transactions and generating trail files. Then ZDM will do an import via data pump from the source to the target. Then ZDM will configure the Golden Gate replicate from the OCI marketplace image on the Golden Gate Hub, and will start actually feeding from those trail files generated by the extract and applying the changes on the target. And finally, ZDM will do a switchover and finalizing the migration process. Finally, we have the logical online migration with a backup location. This methodology, of course, uses a backup location and a Golden Gate Hub that has two microservices, one acting as an extract and the other one acting as a replica. Now, the next set of slides are going to be talking about each one of the steps in more detail. So I'm going to move on and continue with the presentation and talk specifically about this migration methodology in each one of the slides to come, so we can actually go in depth in each one of the steps. Now, before moving forward, let's step back for a second and see the overall architecture. We have ZDM running on an Oracle Linux 7 box. Then we have the on-premises database. We have the target database cloud service. We have a backup location, and then we have a Golden Gate Hub. That Golden Gate Hub is created using an OCI marketplace image, specifically designed for ZDM and the database migration service, and has specific licensing, and right now it allows for 183 days of usage. Of course, this can change, but right now the license is allowed for 183 days of usage for that specific Golden Gate marketplace image. These are all the components for logical online migration with the backup location, and right now what we're going to do is see step by step how that would work. The first step, of course, is to download ZDM, set it up on an Oracle Linux 7 box, and do all the proper configurations. That means pre-filling a response file with information of the on-premise source database, the target database cloud service, Golden Gate Hub information, backup location information, migration methodology, etc. Second step, ZDM will connect to the source and the target database and perform all the required validations to see that everything is in place. Do remember, however, that ZDM does allow for an in-flight upgrade option for logical migration, so in this case, it is valid for the target database to be on a higher level or a higher level version than the source database on premises. Once the validations have been done and all the checks are in place, ZDM will continue to the next phase. The next step is ZDM validating connectivity to the backup location, connecting the source to the backup location and the target to the backup location, and being sure that everything works in that regard. Once all the validations for the backup location have been done, ZDM will proceed with the next phase of the migration. Moving forward, ZDM will then start the migration process, the actual migration, by configuring an Oracle Golden Gate image from the Cloud Marketplace on the Golden Gate Hub, and this microservice will actually be an extract, right? So that extract will start capturing transactions from a source database and generating trade files that will be later used by a subsequent microservice that will be the actual applicant. ZDM is now ready to start the network data pump export job from the source database and start transferring those dump files from the source database to the backup location. Then ZDM will start a data pump import job into the target database using the dump file for the backup location. If the target database is an autonomous database, then this is completely done automatically. The autonomous database will do the import. If the target database is an OCI database like Database Cloud Service or Exadata Cloud Service or Exadata Cloud Customer, in that case, ZDM will copy or transfer the backup location data dump files into the target Database Cloud Service, and then will instruct the target Database Cloud Service to perform the import job. Once the import job is finalized, we have an instantiated database on the target Database Cloud Service. So then, ZDM will proceed to configure an Oracle Golden Gate microservice from the Cloud Marketplace. These microservices will act as a replica that will actually feed from the trail files generated from the extract that is connected to the source database. Now, this replica will feed from those trail files and start applying changes on the target database in the cloud. Once we have that in place, ZDM will start monitoring to be sure that the database achieves full synchronization. And once full synchronization has been achieved, ZDM will then proceed to perform the actual switchover, which is the next step of the migration process. Finally, when everything is in place and fully in sync, ZDM will proceed to switch over the clients to the target database in the cloud, and then finalize the migration by doing a full cleanup of all the different connectivity environment, and of course, after having done all the different checks and evaluation that everything is in place, the target database is fine, and everything is properly migrated. So then ZDM, of course, have provided here, as you can see, a fully logical online migration, of course, always online, and the application now points to the target database in the cloud. We have now covered all the different features and functionalities, different migration workflows, different ways that ZDM works. So as you can see, ZDM is the best-in-class solution for moving your databases to the Oracle Cloud. It offers a wide array of migration sources from databases hosted on Linux, AIX, Oracle Solaris, and now Oracle databases hosted on AWS RDS. We can migrate databases 11.12.4, 12.1, 12.2, 18, and 19c. You can also have a wide array of migration targets, so you can actually migrate your databases to Database Cloud Service, bare metal, virtual machines, autonomous database, both in transaction processing and their data warehouse, both in shared and dedicated fashion, Exadata Cloud Services, Exadata Cloud Customer, and of course, the Exadata database machine on premises. ZDM has multiple migration workflows, logical and online, both leveraging best-in-class solutions and best-in-class tools from MAA. So we leverage RMAN, DataGuard, DataPump, Golden Gate, and all the built-in technologies from Oracle database. Also, we offer new features and functionality, best in class for them for migration, such as physical data transfer, existing Argon backup reuse, the existence of a pre-migration advisor, and of course, really important, ZDM is cost-effective because it's a free tool and also leverages specific licensing for different tools. For instance, the Golden Gate microservices from the OCI Marketplace that have a specific license for ZDM usage and DNS usage when migrating your databases to the cloud. So overall, ZDM is the best solution for you when you're moving your databases to the Oracle Cloud. Now, we have created a lot of resources regarding zero downtime migration for your benefit. You can start visiting us at our product page, www.oracle.com/go-to/ZDM. There you can find the product documentation, licensing guide, user manuals, and we've also created step-by-step guides for you. We have a physical migration step-by-step guide where we migrate an on-premises database to DBCS and or XSCS. Then we also have a logical migration step-by-step guide that covers an in-flight upgrade. So we're migrating an 11.204 database from on-premises to DBCS or XSCS, and we tell you how that works on a step-by-step fashion. So please visit us at www.oracle.com/go-to/ZDM. And now, thank you for all your attention.